Good morning, students. Today we are going to discuss our next topic, that is the reactions taking place during the recharging of a lead storage battery. So we have studied lead storage battery is the secondary cell. Secondary cells are those cells in which the reaction can take place in both the direction. The electrode reaction can be reversed. So yesterday I have told you can reverse the reaction. Same thing is happening here during the recharging of a lead storage battery. One thing which you will keep in mind, during the recharging of lead storage battery, water is used. So at anode, you are very well aware that oxidation will take place. And what is oxidation? Loss of electrons. So at anode, which reaction is taking place? Lead sulfate, which has been produced earlier during the discharging of the lead storage battery. Now this lead storage battery will react with water to form PbO2 plus 4H positive ions plus SO4 2 negative ions plus 2 electrons. 2 electrons will be produced during this process which is taking place at anode. The process is known as oxidation. And at cathode, the reaction which is taking place at cathode is a reduction. Lead sulfate is gaining 2 electrons to form lead solid plus SO4 2 negative ion. And you can add both the reactions. Both the electrode reaction can be added and the overall redox reaction will become 2 PbSO4 plus 2 H2O give rise to PbO2 plus lead solid plus 2 H2SO. So, the next topic is nickel cadmium cell. Nickel cadmium cell is commonly used. It is also a type of secondary cell, and secondary cell means the electrode reaction can be reversed in this case, and the reaction which is taking place at anode. At anode, oxidation will take place. Cadmium is reacting with 2 hydroxyl ions to form cadmium oxide plus water molecule, and 2 electrons will be liberated during this process. You can easily see one oxygen is combining with cadmium oxide and it is forming water along with formation of cadmium oxide. And at cathode, reduction will take place. Reduction is what? Gaining of electrons. Nickel hydroxide. Here nickel is present in +3 oxidation state. It is gaining how many electrons? One nickel is gaining 1 electron and 2 nickel atoms they are gaining 2 electrons. So it is forming NiOH twice. There is change in oxidation state of nickel from +3 to +2, and it is gaining how many electrons? 2 electrons, along with formation of a 2 hydroxyl ion. 2 hydroxyl ions are formed here. Now you can write here, you can observe that 2 electrons are produced and these 2 electrons will be consumed here, while hydroxyl ions which has been consumed here, they have been produced here, so they will also be cancelled out, and here we will write the overall redox reaction. And you can add this oxidation half and a reduction half reaction. So cadmium solid plus 2 NiOH thrice plus, so it will form cadmium oxide plus 2 NiOH twice plus H2O. So this is the overall reaction which is taking place in case of a nickel cadmium cell. It can be commonly used in transistor as well as in cameras, and this can provide a constant voltage of a 1.2 volt. Next topic is H2O2 fuel cell. Hydrogen gas is used, oxygen gas is used in this type of a cell. So at anode, oxidation will take place. Hydrogen is reacting with 2 hydroxyl ions to form 2 water molecules, and 2 electrons will be liberated. At cathode, reduction will take place. Reduction is gaining of electrons. O2 plus 2 H2O plus 4 electrons will form 4 hydroxyl ions. Now there is a requirement of 4 electrons. Only 2 electrons are produced, so we will multiply this equation by 2. By writing the overall equation, we will get H2 gas plus O2 gas give rise to water liquid. And this H2O2 fuel cell is highly efficient cell. There are certain advantages associated with this cell. Highly efficient cell, and one more thing, it is eco-friendly. Eco-friendly. Why this cell is eco-friendly? Because only water is the side product. So only hydrogen and oxygen, these are the gases which are combining to form water molecule. So this cell is what? An eco-friendly cell.